Okay, so we're not going to do every question. We're just going to start with the second one. I just did a random assortment through this. So most of the graph and calculator questions, they're either going to be quadratics, cubics, or sinusoidals. One of those three. So last week we were practicing with sinusoidals. The week before that, we did a couple of the polynomials. I just want to do this one more time with you because we really have had quite an interrupted unit just with all the things with grad and everything. So the key thing that you can do to help yourself with this calculator is not to be on autopilot. So actually think about the scenario. If you think about the scenario and what you imagine the graph would look like, it will really help with your window settings. Window settings are absolutely important because the calculator can only find what it can see. So if you're looking for an x-intercept and the x-intercept isn't on your screen, your calculator can't find it, and you're just going to keep getting back an error message. And because I'm not allowed in the diploma and I can't fix your calculator for you, you need to try to cut down on those errors so you don't get the error messages. Okay? So the first thing to note here, so it says a fireworks display involves launching a rocket into the air. The height in meters of the rocket t seconds after it is launched is modeled by the quadratic equation. So if we think about just generally, like without even punching this thing into my calculator, you've got height and time. You're going to launch this thing, right? So that rocket, it's going to, what's it going to do? It's going to go up and it's going to come down, right? It's going to look like this. Now, this picture should look like that. I'm already seeing a problem. I think there's a negative missing possibly. Anyway, we'll fix that in a second. Um, there is a starting and stopping point. There's not arrows on it because you can't have negative height and you can't have negative time. So we only want to draw this thing in quadrant 1. Now, those of you coming from 20-2, you did hundreds of these. 20-1, you did these more algebraically. Okay? So this HT is just another way of saying Y, and the T is just another way of saying X. Okay? Now, I think it's supposed to be -3, I think. Okay, now, right now, if I were to punch that equation in, I'm going to have an error message on my calculator. Do you know why? What's the problem? This, right? If that is bolded, all the other features of your graphing calculator are null and void. So I did a regression on Friday, which is why that is bolded. Hey, just grab one. So I'm just going to go up, hit enter, and come back down. Okay. I'm going to make it a -3 because I think that's what I need to do here. Whoops. -3 x minus 2 squared plus 50. So yours looks like a negative. Mine look like a positive on mine. So other thing, make sure that you're making this a -3 and this a subtract 2, right? The negative and the subtract mean something different. Now, I'm just going to go zoom 6. So zoom 6 is your default window settings. So if I go zoom 6, it returns me back. So right now, I can see this rocket. I just can't see the top of it. And all I really want is quadrant 1. I don't want to see any of this other stuff. I just want to see the height and the time. So I'm going to have my minimums go 0, 0. And I'm going to need to make my y max something fairly bigger. So I'm going to go 0. The 10 was fine. I'm going to go 0. I'm going to make that 100. It looked like I had to go up quite far. Typically with the y max, you're just going to do a random guess. Okay. Oh, there we go. So there's our path of our rocket. Okay. So remember on the diploma, you always want to put your window settings. So the x went from 0 to 10. The y went from 0 to 100. So you always want to include window settings whenever you draw the picture. Only for long answer questions, right? If it's multiple choice, they don't care. They're just paying attention to whether you circled C or not. So, key questions. Okay. So, what is the maximum height that the rocket reaches, and at what time does it occur? So, the maximum height is that point right there. So, in grade 11, you call that the vertex. Okay. We're calling it a turning point. Remember, a peak and a valley. So, we're just calling it a maximum. So, on your calculator, you're going to pick number 4. Okay. So, where we find that is under second trace and number 4. So number 2, number 3, and number 4, they're all solved the same way. You do a number on the left, you do a number on the right, you hit enter to get past guess. If you don't want to enter a number, your teacher last year might have had you scroll to the left and scroll to the right. My scrolling feature doesn't work, so I'm going to put a number in. Okay, so number 4 for maximum, that's our peak. So I am looking, so ignore, this means nothing, right? Ignore that cursor. For me, I'm going to ignore it. I'm just looking for this. So remember, I went from 0 to 10. So a number on the left, I'm going to pick as 1. A number on the right, I'll pick as 6. So number on the left, I'm going to go with 1. A number on the right, I'll go with 6. You could scroll to the left, hit enter, scroll to the right, hit enter. Okay. Hit enter to get past guess because it means nothing. So there we are. So our x is 2 and our y is 50. So x is 2, y is 50. So what does that mean? It means 2 seconds after takeoff, it had a maximum height of 50 meters. Okay. You should have done a ton of those last year. Okay. Height at launch. What is the height of the rocket the moment it is launched? So the moment it is launched is right here. That is the y-intercept. It's where it crosses the y-axis. The way we find the y-intercept is we use number 1. So number 1 is different than 2, 3, and 4. So second trace, number 1. So the power behind number 1 is you can plug any number you want in for x, and it will give you out the matching y. And you can plug in anything, as long as right now it's a number between 0 and 10. If I plugged in 27, I'll get an error message. Okay, but if you plugged in 1.84825, it would find the matching y. I just need to know this point right here. So my x-coordinate is 0. So if I hit enter, the y is 38. So it was launched from a height of 38 meters. Okay, this one I tend to find when I taught grade 11, it's been a couple years since I taught grade 11, but this one is the one that most kids struggled with. At what times will the rocket be on the ground? It should be at what time, not times. So when it hits the ground is right here. That's when it hits the ground. That is an x-intercept. X-intercept, we use number 2. So it's the exact same thing as maximum. It's number on the left, number on the right, or scroll to the left, scroll to the right. So second trace, number 2. So I'm looking for this guy right here. Okay. So a number on the left would be anything from 0 to 5. I'll go with 3. A number on the right would be 10, 9, 8, or 7. I'll go with 8. Most useless feature ever. Just hit enter to get past it. And there we are at 6.08. So let's make it 6.1, nearest 10th. So again, just to remind you here, so 10th would be 6.1. 100th would be 6.08. So again, just pay attention to the rounding. It's gonna, for some of you, The rounding has been the bane of your existence. Like if we were to go through all of your unit ends, some of you have lost probably 5% off of your mark total because of every question you got wrong on unit ends because you rounded wrong. Okay? You've got to make sure and read that question properly. Okay, lastly, what is the height of the rocket 4 seconds after it is launched? So 4 seconds is an x value. Okay? So if we know what x is, that means we're looking for y. So again, we're going to use number 1. But this time, instead of plugging in 0, I'm going to plug in 4. So second trace, number 1, x is 4. So 4 seconds after takeoff, it has a height of 38 meters. Okay. I know I haven't given you much space. Oh, there's actually a little bit there. Put question number 5, please. And write this question in. At what time, and then in brackets S, at what time or times is the rocket 42 meters off of the ground? Okay, so remember, this is height, this is time. So I've given you a y value. I've given you the height. So the height is 42. So the way we solve this question is we're going to plug that into y2, and it's going to draw a horizontal line through the graph. And what we're looking for is where it intersects. And there's going to be 2 answers. Now, intersect is different again. Everybody likes intersect because you just have to go enter, enter, enter. You just have to hit enter 3 times, and it will give you out the answer. So pick a y, it doesn't matter which one, and enter in 42, and you're going to get a straight line. We did a ton of these in exponents and logs, right? We did either an exponential growth with an intersect or an exponential decay with an intersect. We did it over and over and over again. So all I've done is change the unit. I am not changing the process. So I just need to find this intersection and I need to find that intersection. So second trace number 5 is what's going to do that for us. Now here's where you do want to pay attention to that little cursor. If I hit enter, enter, enter right now, it will find whatever intersection point it's closest to. So it will find me this one, which is fine. 1, 2, 3. It found me that one. So 3.6 seconds. Now in order to find this one, I need to do the process again. So second trace number 5. But I have to move the cursor so that it's closer. It just has to be closer. It has to be closer to this than that. You don't have to put it right on top. You just have to move it closest. Hit enter 3 times. And there we go, 0.37. So on the way up, it hit 42 meters, and on the way down, it hit 42 meters. So 0.4 seconds and 3.6 seconds on its way up and on its way down. So that one question, we pretty much covered all the buttons. The only thing we didn't cover was number 3. Number 3 occurs when you have a valley. When your curve has a bottom, our curve had a top. So if our curve had a bottom, then we would use number 3. Our curve has a top, so we use number 4. Okay? Does that kind of bring back some memories for you from grade 11? Okay? What the? Okay, there we go. We've practiced it with exponents and logs a little bit, but exponents and logs was 2 months ago. So she's been a while. Okay. Okay, let's take a look at this one. So I think it's number 5. I don't know if I numbered them or not. I think it's the top of the second page or third page or however you're counting. So I picked this one because it is a cubic. Okay, so please don't push this into your calculator yet, just pause. Okay, so just like with quadratics, we want you to imagine what that path would look like, right? We wanted you to imagine that rocket, right? It gets fired, it goes like this. So you know you're dealing in quadrant 1 because you have positive height and positive time. Cubics, so I went through a whole bunch of patterns with you with cubics, okay? One of the first patterns we learned was that this is called the constant term. The constant term is the y-intercept, okay? The second thing we learned is that the highest power is called the degree, and the number in front of the highest power is called the leading coefficient. Now, the leading coefficient controls how the graph ends. So because the leading coefficient is negative, then the graph is going to finish by going down to the right. So I know it's going to have a y-intercept of 10. I know it's going to finish going like that. Now, because it's a cubic, cubics have peaks and valleys, right? They have one peak and one valley, or they do that little wiggly thing. Do you remember the proper name for the wiggle? Point of inflection, right? That's when you kind of had, it looked like it was going to peak and it's like psych, right? And it kind of kept going. It's a little wiggle, okay? So these are turning points, peaks and valleys, valley and peak, turning points. This one doesn't have a turning point. It's got what's called a point of inflection. So mine is going down. Mine is going down. It's got a positive y-intercept. So I'm betting mine is going to look something like that. So without even plugging anything in, I want to keep that kind of thought process in my head. Because here's the thing. If this was plus 1,000, that would mean my y-intercept was 1,000. Why is that important? Because that helps me know what my y max should be, right? And because I'm going down to this side, I want to make sure that I can see both those quadrants. Okay, so just again, taking some of those patterns before we even punch anything into our calculator. So if we go back and read the scenario here, it says a company is designing a new roller coaster with a unique feature. The height of the track at different points along the ride is modeled by a cubic polynomial. The height in meters of the roller coaster, so this is the height in meters, and a horizontal distance in meters. Okay, so it's not height and time, it's height and distance. So both x and y are in meters. Okay, we're not talking meters and seconds, we're talking meters and meters. From a starting point is given by this. Okay, so let's plug this thing in because I have no idea what this thing's going to look like, except for those couple patterns that we just did. So remember your power key is right above the divide sign. So power 3 plus 3x squared minus 2x plus 10. Okay. So I'm just going to go zoom 6 to return my window settings back to normal because remember I monkeyed with them on the last question. So I'm going to go zoom 6 and see what I've got. Okay, I got a tiny little dip right here. So I need to go up here and up here. So I need to make my Y max a lot bigger. So Y max, I'm going to make it 100. Now technically, I don't need negative x's or negative y's because you can't go negative distance, you can't go negative height. So if I wanted to get fancy, I would go 0, okay? But you don't have to do that if you don't want. Oh, so there's the path of my roller coaster, right? So it's going like this, okay? It's all good. If you wanted to keep those as negatives, whoops. Instead of going to 100, I'm going to go to 50 just to make it. There we go. So this doesn't mean anything to us. That doesn't mean anything to us. Okay, just grab a piece of paper here. Okay, so I'm going to go back. Okay, I'm just going to leave it like this. So we can see it has a y-intercept of 10. It goes down on that far right side because the leading coefficient was negative. It's got one peak and one valley. Okay, so what did it look like? Like that, something like that. I suck at drawing. Okay, so going through now, we're going to use the same menu, but the wording of the questions changes because the equation is different. So it says at what horizontal distance from the starting point does the roller coaster reach its maximum height? What is the maximum height? So again, maximum. So again, we're going to use number 4. Okay, so I am looking for that. So again, I'm just going to change my window settings. This is bugging me that I can see the negative. Right? That's the maximum height. Notice how the graph went forever this way? That doesn't count as maximum because you can't have negative distance. Okay. So second trace number 4. So either scroll to the left, scroll to the right. I'm just going to punch in the number 1 and the number 8. So 3.6 meters and 18.4 meters. So it reached its maximum height of 18.4 meters, and it did it 3.6 meters from whatever starting point we're looking at, because they're both in meters, they're both distances. So at what is the horizontal distance? That's 3.6 meters. What is the maximum height? 18.4 meters. Okay. What is the height of the roller coaster at the starting point? So this is the y-intercept. So the way we find y-intercept is use number 1. So we're looking for this right here. And again, you enter in 0 because you want to know where it's crossing this point right here. So 10, y-intercept. Now, remember those patterns? Did you already know your y-intercept? Yes. So you didn't even have to use your calculator for that if you don't want to, but it's there. At what horizontal distance from the starting point will the roller coaster be at ground level? Now, this is kind of a stupid question because if a roller coaster is at ground level, it's not going to end well for the people on the ride. Like, it means you're hitting the ground. Unless they've like physically removed dirt and you actually go like underground or something, you don't ever want to be on a roller coaster at ground level. Okay, it's kind of like a Ferris wheel, right? You always want to stay above the ground. But for argument's sake, what we're looking for here is the x-intercept. So that is using number 2. So second trace, number 2. So again, I'm looking for this thing. So a number on the left, a number on the right. So I just went with 2 and 9. Hit enter to get past guess. So 5.9 meters. So from whatever point they're starting at, this thing went 5.9 meters from the starting point to when it was at ground level. I'm going to hope for the sake of these riders that they dug the ground away and that we're not looking at a mass casualty event. And then finally, what is the height of the roller coaster? 4 meters horizontally. So again, 4 meters horizontally, that is an X value. So whenever we give you X and you're looking for Y, we use number 1. Whenever we give you Y and you're looking for X, we use number 5. So 18 meters. So 4 meters from its starting point, it reaches a maximum height of 18 meters. Okay, so almost identical questions to the first one. It's just that, again, the picture has changed because we're talking about a cubic graph instead of a quadratic graph. Okay, yeah, my picture is bad. The picture looked more like that. Okay. Questions. So the buttons don't change. What you're finding hasn't changed. It's just the picture is changing. Okay. Okay, one more I want to do with you, and it's going to be a sinusoidal. So this is what we did on Friday or Saturday, or Thursday. So it's the last one in your booklet. So all the way on the very back side. Okay, so it says a coastal town experiences tides that can be modeled by a sinusoidal function. The height of the water, h meters, relative to the average sea level at a time t hours is given by the equation. Okay, so again, this is height, this is time. Think of it as y and x. Okay, here's the key. The key is your x min, x max. So x here is in hours. We're told that in the question. What you typically want to do is think about the context again. Even if we live in Tabor, it's not like we're beachfront property here. But the idea being is that tides come in and go out through the moon and gravitational forces and all that. Typically, over a period of a day, they go in and they go out usually twice. Usually, not always. Okay? So tides change every day. So if we think about wanting to see one day, but our units are in hours, what we would want to go is 0 to 24, because 24 hours is one day. Does that make sense? Okay. Now for the y, you can use all the theory that we've been learning about. This is your a, this is your d. So without drawing anything, we know that our midline is at 5. And from that midline, we're going to go up 2 and down 2. So our top should be 7, our bottom should be 3. So that means for our y window settings, 0 to 10 will work great. So trying to get you guys to combine a little bit of theory with the button pushing on the calculator is what you want to be. Okay? One more thing before we punch this thing in. On your calculator, hit mode for me. So just hit the mode button. Now, when you walk into your exam tomorrow, I will reset your calculators because resetting it puts it back into radian mode. you must be in radian mode for anything we do with sinusoidals. So radian mode is the default mode on your calculator. So if I set it for you, you don't have to worry about it. Okay. If you're borrowing a calculator from me, especially when it comes time for the diploma, when you walk into the diploma, your calculator is going to be reset back to radians. It's just that if you're borrowing a calculator today and tomorrow, you have to just do a double check to make sure it's in radians because my grade 10s use these calculators and they are always in degree mode. Okay, so you guys have to be in radian. Okay, so if you're not sure how to do that, just move the arrows, hit enter to make it flash, and then it's set. Okay, so let's enter that equation in. So we're going to go, what was it? 2. So it's not a negative actually, it's just the number 2. So 2 sine 0.52x minus 1.05 bracket plus 5. Let's change our window settings too. So I want to go from 0 to 24 because there's 24 hours in a day. And then the other one's going to be 0 to 10 because I already know where my midline and my amplitude are. So hopefully now I get that funky wave. Hopefully. Yep. So the tide height, right? High tide, low, right? This is high tide when the water is super deep. This is low tide when the water is super low. Okay. So questions. Okay. So what are the minimum and maximum heights of the tide, and at what times do they occur during a 24-hour period? Okie doke. So I've got 2 high tides and 2 low tides. The worst part of graphing calculator is the painful button pushing. It just takes forever, but it's not that bad. So if we find our maximums first, so again, this is what I'm looking for. So again, you could scroll to the left, scroll to the right, or you could put a number in on the left and a number in on the right. Remember, you can only do one at a time. You have to do each one separately. So I'm going to go with 2. I'll go with 2 and 7. That works. Hit enter to get past guess. So at 5.0 hours, we get a maximum height of 7 meters. Okay. So first one here, at 5 hours, we get a high tide of 7 meters. For the next one, I'm going to find the minimum next, so the low tide. So I'm looking for this guy. So number on the left, number on the right. I'll go with 7 and 12. Oh, just barely, okay? Hit enter to get past guess. And I get 11 and 3. So 11 hours and 3. And I already knew the 7 and the 3, right? Because I did my basic stuff before. Next high tide, right here. So maximum again. So I'll go with 14 and 20. So 17.1 or just 17. And then the last one, another minimum. I'll go with 20 and 24. And I get 23.2. Okay. Now, that is the number of hours after the starting point, but it didn't tell you the starting point. Most of the time, they start at midnight. So this one would be at 5 a.m., 5 hours after midnight. This one would be at 11 a.m., which is 11 hours after midnight. 17 hours after midnight, that's like 5 p.m., right, of the next day. What is the height of the tide at the start of the day? So at time 0, so again, this is y-intercept. So y-intercept, so number 1, y-intercept by 0, so 3.3 meters is the tide. So it's not at its lowest point. The lowest point occurred probably at like 11:30 p.m. on the previous day, and at midnight or time 0, the water's coming back into the harbor. So 3.3 meters. After the start of the day, at what time will the next high tide occur? Well, we already know that. It's 5 hours, right? Because that's the high tide. What is the height of the tide 9 hours after the start of the day? So here again, x equals 9. We're looking for y. So go ahead and use number 1. X is 9. So 4.1 meters is the height of the water. Okay. So window settings are absolutely crucial. I do want to show you what happens if you happen to be in the wrong mode. I don't see how, if we erase your calculators when you walk in, I don't see how you guys could change the window setting. But if you're accidentally in degree mode, you'll get these flat lines. That's one possibility. The other possibility that can happen with sinusoidals is if you screw up the window settings. So let's say you go 0 to 200, like you just randomly put a number in, it can look like a heart attack. And so with my 30-1s, I use the analogy, like you're either flatlining or you're having a heart attack. Either way, you're dead. Like it's not good for you. So you want that nice, gentle wave. So always check your window settings. If you're getting a heart attack or a flat line, always check your mode to make sure you're in radian. Okay, what you want is a gentle wave. That's your goal. So quadratics, the goal is a smile or a frown. Cubics, it's a peak and a valley. Sinusoidals, it's a wave. Okay, and then you're simply using this menu to find what you need. And you should be familiar with this menu from quadratics in grade 11. Okay, so there's not a separate worksheet. If you want to try some of these on your own, you can just go in and do the ones that we did not do together. The answers are on Google Classroom if you want to do them. But that is that. So while I'm saving this video, be careful of the cord. Go into your file folder and pull open the polynomials quiz, okay? And we're going to go through it together. Those of you that haven't written it, pull it, go out in the hall, and start writing. And I'm going to set this up. Take your break.